A pleasant day to everyone. We hope that all is well with you, and we thank you for this opportunity to share our journey in the revision of the mathematics curriculum. In this session, we will walk you through the revised mathematics curriculum to better understand its silent features with emphasis on the learning standards. It is hoped that this presentation will give you adequate information to be able for you to provide guidance to teachers when they design, develop, and implement their instructional plans. For this session, the following shall be presented. First, the background or the rationale, and the second would be the mathematics framework and its standards. Launched in 2023, the mathematics curriculum was shaped on the findings obtained during the review of the intended curriculum. It went through a tedious process, starting with the curriculum review in 2019. The findings were used as a basis for its design and development through a series of workshops. One of these is the cognitive demand. The findings that the Philippine curriculum has higher expectations compared to international counterparts coincide with the results of the review of the current mathematics curriculum in terms of the level of cognitive demand. Specifically, the level of cognitive demand is concentrated on level 2, which is about performing algorithmic procedures, and level 4, which is focused on analysis. However, it was also found that there is a low rate on the demands of level 3 that centers on communication, and level 5 emphasizing creation and investigation. The curriculum was examined based on these levels as presented here. That's from level 1, which is about memorization of facts and formulas, to level 5, which operates on applying concepts and making connections. And during the revision of this curriculum, the standards and learning competencies were examined and ensured that these cognitive demands on communication and creation or investigation are articulated in the learning standards. The current curriculum has a total of 740 learning competencies. During the review, it was found that 668 of these, or about 90%, are essential. This implies that we have a substantial number of essential learning competencies, or what we call the ELCs. However, it was also found in the review that there were prerequisite competencies that were misplaced, and a learning competency was identified essential based from the characteristics presented in this slide. The distribution of the essential learning competencies and the desirable learning competencies across grade levels is shown in Table 2. So in all grade levels, as you can see, most of the LCs are identified essential. Other important findings are about the sequencing of the learning competencies, curriculum congestion, and time allocation. The review revealed that the curriculum, to a larger extent, exhibited a spiral progression approach in the development of learning competencies. However, the sequencing of some learning content may disrupt the continuity of these competencies and consequently the development of the skills. So here, the developmental sequence of the concepts and its appropriateness in the grade level was ascertained during the revision, as well as its continuity through the mapping of the prerequisite skills within and across other learning areas. Another common observation in the articulation of the learning competencies in the curriculum is that these LCs are too specific and are stated as learning objectives, making the curriculum appear congested. Hence, some learning competencies, especially those which are seemingly learning objectives, were clustered and were stated into a more general form. Additionally, essential learning competencies anchored in the big ideas were prioritized. It was also found that the allocated time for the development and mastery of the learning competencies is not adequate. With the changes on the articulation and the number of learning competencies being covered in this revised curriculum, the TEM again reviewed the time allotment to ensure that there is enough time in developing the essential skills and knowledge mapped in the revised curriculum. Let us now compare the 2016 and the 2023 mathematics curriculum framework. This slide presents a curriculum framework we have and the current curriculum with the twin goals of critical thinking and problem solving, And then the framework of the revised mathematics curriculum with the main goal of developing a mathematically proficient and critical problems. The framework of the revised mathematics curriculum puts premium on its main goal of developing a mathematically proficient and critical problem solver. Examining closely the framework of the revised mathematics grades 1 to 10 curriculum guides the teacher in preparing mathematically rich lessons and helps them recalibrate pedagogies, assessment, and resources in achieving the aspirations of the curriculum. Again, the main goal of the revised mathematics curriculum is for Filipino learners to become mathematically proficient and critical problem solvers. It streamlines and enriches the twin goals of the current curriculum, namely critical thinking and problem solving. To achieve the main goal, three facilitating facets must be placed: a robust mathematical content, a sound mathematical disposition, and a set of strategic skills for applying mathematics in the various contexts. The three facilitating facets must be reinforced by three supporting components focusing on pedagogy, assessment, and resources, with all these three being relevant to the content, the context, and the learning phases of the course. So again, the main goal of the revised mathematics curriculum is to develop Filipino learners who are mathematically proficient and critical problem solvers. But what is mathematical proficiency? So we have here mathematical proficiency is the ability of the learner to use mathematical knowledge and skills and effectively use it in a variety of situations. So it is comprised of the five intertwining strands. So these strands are: we have conceptual understanding, procedural fluency, strategic competence, adaptive reasoning, and productive. One of the features of the revised curriculum is its articulation of problem-solving, critical thinking, and mathematical proficiency as presented in its curriculum framework. So it is important to note that more than aiming for the Filipino learners to become successful problem solvers, the revised curriculum intends to produce learners who exhibit the qualities emanating from the five intertwining strands of the mathematical proficiency. So these strands are, as you know, conceptual understanding, which is about the comprehension of mathematical concepts, operations, and relations. Then we have procedural fluency, which is about skill in carrying out procedures flexibly, accurately, efficiently, and appropriately. Also, we have a strategic competence, which is the ability to formulate, represent, and solve mathematical problems. And then adaptive reasoning, which is the capacity for logical thought, reflection, explanation, and justification. And lastly, productive disposition, which is the habitual inclination to see mathematics sensible, useful, and worthwhile, coupled with a belief in diligence and one's own efficacy. The curriculum also highlights critical thinking, which is the process of resourceful and reflective judgment. It applies skills of interpretation, analysis, inference, evaluation, explanation, and self-regulation in an effort to judge for what to believe or what to do. And also problem solving, which is about finding a way out of a difficulty, a way around an obstacle, or attaining an aim which is not immediately attainable. And that is according to Boyle. So solving problems is not only a goal of learning mathematics, but also a major means of doing so. The articulation of problem-solving, critical thinking, and the intertwining strands of mathematical proficiency is evident in the learning standards in the revised curriculum. This can be exemplified in the Key Stage 1 standards and also evident in other Key Stage standards. So looking at Key Stage 1 standards, then we have here from the bullets the mapping of the intertwining strands of mathematical proficiency. So you have for conceptual understanding, here we have procedural fluency, and strategic competence. So let us see. Acquire high-level skills and fluency in the procedures and processes of mathematics through varied frequent practice and meaningful learning experiences. That means when we say strategic competence, we do not limit the conventional way of solving problems. So let us try to have our students be able to find other ways of solving mathematical. And so we also have communicate and represent mathematical concepts and understanding using development in the appropriate language. And that would be about adaptive reasoning or, of course, communication. And here is productive disposition. So presented here is the mapping of the strands of mathematical proficiency in the learning standards in key stage. So we say here, use efficient mental and written mathematical concepts, operations, procedures, relationships, and tools to solve routine and non-routine real-world problems. This is about conceptual understanding and procedural C. Then we have also here adaptive reasoning, reason and communicate using precise mathematical language to discuss ideas, investigate problems, and justify solutions. So we do not just let them solve problems, but we also encourage them to explain and justify their solutions. Then we have strategic competence, exhibit willingness and confidence to explore alternative solutions and to take risks necessary to solve real problems. So we put emphasis on exploring alternative solutions. So they are not limited to the conventional way of solving those problems. And of course, we have productive disposition and then real problem solving and critical thinking. Now here is the mapping for key stage 3. So we also have here conceptual understanding and procedural fluency, but let's take a look at this bullet. Apply mathematical concepts, operations, procedures, facts, relationships, and tools to describe, explain, investigate, model, and predict phenomena. So we are trying to progress from simply explaining to investigating, modeling, and predicting phenomena. Okay, then we also have adaptive reasoning, wherein students are encouraged to reason mathematically, construct plausible arguments, evaluate the reasoning patterns, and ask useful questions to clarify or improve arguments. Then we also have adaptive reasoning and strategic competence that can be exhibited by accessing, using, interpreting, and communicating mathematical information and ideas to engage in and manage the mathematical demands in the various 21st century. And also, of course, productive disposition and then problem solving and critical thinking. So, to emphasize clearly, the revised mathematics curriculum aims to develop among the learners the proficiency in solving problems critically, grounded in a strong conceptual knowledge, the strategic use of mathematical skills and processes, and the desirable values and disposition in mathematics, thus enabling them to become productive and successful 21st century citizens. Let us now look into the features of the 2023 mathematics curriculum. On curriculum goals, how do we compare the current curriculum and the revised curriculum? We have critical thinking and problem solving as the twin goals of the 2016 mathematics curriculum. So in the 2023 curriculum, we would like to highlight the learner that we envision, that is, a mathematically proficient and critical problem solver. In the 2016 mathematics curriculum, the content standard centers on the 5 content domains, which are number and number sense, measurement, geometry, patterns and algebra, and statistics and probability. So as we decongest the content of the learning competencies in the revised curriculum, we now have 3 content domains that are anchored at big ideas, namely number and algebra, measurement and geometry, and data and probability. And so we would like to emphasize here that all of these are interconnected. Comparing the current curriculum and the revised mathematics curriculum on the number of learning competencies, we can say that there is a reduction of about 30% in the number of learning competencies. That's from 740, we now have 506 learning competencies. Another feature, we have an enhanced articulation of the standards and competencies in preference for employing the engineering design process in the learning task, highlighting the interrelation of concepts and other learning areas such as science and technology, and also in promoting STEM. This means that mathematics teachers may collaborate with other learning areas such as science and TLE to be able to come up with one performance task focusing on solving real-life problems employing the engineering design process. There is also a strengthened articulation in the 21st century skills in the standards and competencies. So the 21st century skills framework of DepEd is also included in the BEDP 23. So examples of the strengthened articulation of the 21st century skills in the standards and competencies are presented in this slide. So let us take a look. For grade 2, we have compose and decompose composite figures made of squares, rectangles, triangles, circles, half circles, and quarter circles using cutouts and square grids. So this is about learning and innovation skill, developing learners' creativity and critical thinking skills. And for grade 5, we have here identified appropriate graph, bar graph or line graph, to represent a given set of data. So this is not just about identifying the graph, but also determining its appropriateness in representing a given set of. We also put premium on the development of foundational skills to strengthen early numeracy. So as an example, in grade 2, we have a learning competency which is about reading and writing numerals up to 1,000. So this entails firming up the representation of numbers in symbols as the learner is still developing their language facility. So it's not about reading and writing numbers in symbols and in words, but we focus first on reading and writing numbers in symbols. As you know, learners are not still on developing their language facility. So again, from 5 content domains in the current curriculum, we now have 3 to emphasize the interconnection of these domains. So we have number and algebra, measurement and geometry, and then data and probability. So for number and algebra, starting with patterns involving numbers, shapes, and their attributes, in the early stages of learning, the revised curriculum presents the algebraic perspective of numbers in the middle stages of learning, and then later on the notions of equations, functions, and analytic geometry. For measurement and geometry, which shapes their properties and their geometric measurements in the early year learning stages, the discussion on geometry continues to its axiomatic development, advanced concepts, and proofs in the later part of the learning process. And for data and probability, that's from simple collection and representation of data to understanding the terms likely, more likely, and most likely as simple concepts of probability, the discussion progresses into methodological, graphical, and numerical interpretations and computations of data, experimental and theoretical perspectives of probability, and the counting techniques in the middle and later stages of learning. So let us examine the progression of the standards in the key stages of the mathematics curriculum. For key stage 1, it focuses on grades 1 to 3 learners. In the curriculum addresses the development of early numeracy by focusing on the learner's understanding of 1 to 4 digit numbers, measures, basic shapes, and simple data. It also develops their fluency in carrying out procedures or operations involving the mathematical objects in their various representations, which could be concrete, contextual, verbal, visual, and symbolic. And so the mastery of early numeracy concepts lays the groundwork for understanding more complex mathematical concepts and solving more complex problems. And then for key stage 2, it focuses on grades 4 to grade 6 learners, wherein at this stage, the curriculum extends numbers, algebra, measures, geometry, data, and probability. So the coverage includes more complex properties, operations, and problems in different contexts that demand efficient written and mental methods of calculation. And for key stage 3, the focus is on the algebra, measurement, geometry, and data and probability, with greater emphasis on cognitive development towards self-directed learning. In all key stages, mathematical objects are in their various representations: concrete, contextual, verbal, visual, and symbol. And learning experiences include explorations of mathematical objects and operations that will engage learners in a variety of thinking processes in real, situated, and purely mathematical contexts. So the goal of the learning experiences is to support and strengthen the young learner's interest and appreciations of mathematics as a tool for solving problems and for communicating ideas in everyday situations. And so we all share the same vision of championing mathematics education and making a difference in the lives of our learners and in society in a bigger scale. So the vision can be realized if this curriculum will be translated into a living document that will transcend from this generation. So thank you very much for your kind attention on this presentation. Magandang umaga.